Welcome athletes to our video on composition of functions. We're working in section 1.8, and to start out, there's a number of ways you can combine functions or compose functions together. And one way is arithmetically. So you can combine functions by using our basic four operations: sum, difference, product, quotient, right? Sum is to add, difference, subtract, product, multiply, and quotient, divide. So you can see these different notations here for each of the ones. This is the notation that makes a little more sense to me. Like when you add two functions, f of x plus g of x, here f of x minus g of x, f of x multiplied by g of x, f of x divided by g of x, right? This notation is also common in textbooks and things like that. So I want to make sure that you are exposed to that and see that, are familiar with that. So, again, means the same thing. F plus g of x means the same thing as f of x plus g of x, just another different way to write it. And remember that this doesn't mean f plus g multiplied by x. It means f plus g as a function of x, right? And the same thing here, f minus g as a function of x, f multiplied by g as a function of x, f divided by g as a function of x. And again, those mean the same things. I tend to prefer and lean towards these notations, but you'll kind of see them both throughout the textbook. And, just make sure that you can use whatever one you want as you're kind of writing or describing what's happening. But in terms of, when you see a problem in a textbook or on a quiz or a test, just make sure that you understand what to do in each of the situations. Okay. And speaking of what to do, this is an example here. So if we do have these two functions, f of x, let's use that kind of in blue, and then we have g of x, and let's kind of color code that one in green. And so if we're doing the sum, combination here, then we would take our f function, right, and we would just add it to our g function, right? So f of x plus g of x, just what you would think, 2x minus 3 plus x squared minus 1, right? And then we would combine like terms here. We have the negative 3 and the negative 1, so that's how we get to the negative 4, right? And then the x squared doesn't have a like term, so that goes to the front and is our leading coefficient, and then the 2x just comes right behind it, okay? So that's an example of using the sum way to combine functions. Next, we have our difference. So here we have f of x minus g of x, right? So same thing as you saw earlier. It's 2x minus 3 minus x squared minus 1, right? So same thing, but now we are subtracting instead of adding, right? And when we subtract, it's going to be very similar, except for this negative changes the signs, right, of all the terms on the inside. And so we end up with a negative x squared, right? 2x is still positive, so that comes down right there. And then our like terms, negative 3 and positive 1, right? Because it's a negative there. And so negative 3 plus 1, it comes out to negative 2. All right? So that's what would happen if we subtracted f of x minus g of x. And by the way, we could do this the other way. We could say g of x minus f of x, right? We could switch the order of f and g and subtract that way, right? And our answer would be a little bit different. It would be the opposite of what we just got. So the signs would all change. All right, then we have product, where we would multiply f of x multiplied by g of x. So you can see similarly, where it's f of x and g of x, but this time instead of adding or subtracting, we're multiplying those together, right? And so this would involve FOIL. So we would, or just distribution, if you want to think of it that way, but FOIL, first times first, so we get our 2x cubed, and we multiply the first terms together. Outer times outer, right, is what the O stands for in FOIL. So negative 3 times negative 1 is how we get positive 3. Then we have inner, negative 3 times x squared is how we get negative 3x squared. And then we have last times last, right? Negative, I messed up. Sorry. So when I said outer, I said negative 3 times negative 1, which is positive 3, but that's actually our last times last, right? Our outer 2x times -1 is how we get the -2x there. All right, and so then that's how we get this entire thing, is by multiplying those together. Sometimes you have like terms, you'd be able to combine them and things, but in this case, yeah, there weren't any like terms once we multiplied. All right, and then the last one is the quotient. So so here we're dividing our two functions, right? So again, we're dividing f of x divided by g of x, right? And in this case, there's not much we can do to simplify. We could try to, factor and cancel, but there's nothing that would work to cancel here. But so sometimes there's division is a little more involved, but in this case, that's as far as we can go. So we would just leave it as it is right there. And so this would be f of x over g of x, or f of x divided by g of x. And remember, the key is that the denominator can't be 0. And so that's where this x cannot equal plus or negative 1, because if x was positive 1 and we squared it, we would get a 0 here, right? And if x was negative 1 and we squared it, we would still get 1 minus 1, which is 0, right? So these are the values that x cannot be. And that's basically what the domain is. X is anything but 1 or negative 1, okay? These other ones, in terms of domain, the domains would be all real numbers when you're talking about polynomials, because you can add, subtract, multiply, raise any number to an exponent. You can do all those operations with any number. The only thing you can't do is you can't divide by 0. And so whenever you're bringing in division, then you have some limitations that could affect the domain. And in this case, you can see that we do have a change in the domain where x cannot be 1 or negative 1, but it can be any other number. All right, so that is how to combine functions with our 4 operations: sum, difference, product, and quotient. And remember, again, these are the notations that you'll use in those cases. So when you see those things, you know how to operate with functions, just like we would operate with numbers, except now we're combining functions, right, with x's and our variables in the mix and things like that.